Okay, well, I'm up. So we should start on time. Everybody's very stressed about that. Hello, everybody. My name is Ale Contenti. I'm the dev manager for Visual C++. Welcome to Build this year. Hope you had a great lunch, first day, lots of talks. Today I'm here to talk about C++ and Project Austin. Project Austin is, or just Austin, is a Windows 8 application that we built. When I say we, I mean the Visual C++ team. Among you, how many are familiar or know about Project Austin, or see the video, or downloaded the code, or few people? So let me just spend more people. Did you change the code already? Not yet, good. But you should do it. So let me just talk just a couple of sentences about what I think is Austin, right? Austin is a simple application. It looks simple. It's just like this notebook that I carry around all the time, And now I stop because I have Austin, so I'm going to throw this away. It's just paper and pen, and it's not super fancy. You cannot search, but you can, scribble and write down ideas, write down notes, write down, what your wife tells you, stuff like that. It's very fluid, it's very natural, right? It's real to life. And in C++, in my team in general, we really believe in this kind of application that, they look simple, but they respond very well. They give you a good feeling. And we wanted to validate that actually with our tools, with Visual Studio, with Visual C++, you can actually write this type of applications. So that's why we set out, a couple of developers for a year, basically, to write this application. So that's what it is. So let's go in. And we also had a lot of fun writing it. So that was one thing. So this is the agenda for today. We're going to talk a little bit more in detail. I'm going to show you a demo of what Austin looked like, why we built it, and, the ideas we pushed, inside Austin to, use modern C++ and other things that we want to teach people and to learn from ourselves. And I'm going to show you, we are going to go deep down in a couple of problems we found while we were building Austin, especially around performance and responsiveness. And so we are going to drill down on how we made a couple of loops, more performance because we need real-time efficiency there. And, I really hope that, you're going to understand. It's not super easy to write these applications, but it's fun, it's rewarding, it's the apps that we believe are going to, do well in the store. So I really believe I'm going to inspire you to write these applications or something like that to embed something of this inside your application. So go build great apps, makes a lot of money, makes us happy, so I can download your apps. Okay, so Austin, we said, is a digital note-taking application for Windows 8. You can add pages to your notebook. You can use digital ink to write, draw, different colors, different pens. You can add photos also. That's one of the features we added. And in general, you can save or email, pages of your notebook around. That's very simple overall, right? I took a picture of my notebook here. So let me show you actually the stuff, the real application working. I have to press the magic button here, and it's working. Look at that. So you basically start. It's nice to have a touch screen, of course, and a pen. So these are some notes, very important work notes. So where to go eat tonight, gelato, pizza. In general, you see you can turn the page. You can turn the page very naturally. There is shading. There is a lot of direct text written here. And it's very nice. You can, of course, make it bigger, make it smaller. See this transition very natural. You can look at the speed. For example, you can see here. Look at the speed of the transition here. There's inertia. You can go back and forth. You can add picture. You can, we added also thanks to XAML UI, we added, normal Windows 8 concept like the up bar or, change color. Which one is the color of Windows UI? Yes. You can write with a pen. It's very natural, You can, just go back and stuff like that and draw stuff here and so on, Take notes. I mean, it's very natural. It looks real, It's useful. You can delete stuff, for example. I want to delete this one, stuff like that. So, for example, you can delete a page, and it's gonna kind of migrate automatically. So it seems he adds very fluently, but there is actually a lot of code that goes there. A lot of it is done in real time, ink smoothing and so on. So we are going to see a little bit of all of these as we drill down into the code. So it's not on the App Store yet, but it's on CodePlex, and you can download the code and recompile it for yourself. I have to find this one. So why we built it? So we wanted to, so this, we want to definitely show off the power of Windows 8, the platform, the power of the stylus and the touch, the power of DirectX, the power of C++. And we used a little bit of all these things. We didn't really set out to use, Vectorizer or C++ AMP. We were just facing some problems, and we say, okay, let's solve the problems with the tools we have available. And so it's written in modern C++. We took great care in actually leveraging existing libraries, modern C++ concept. We used a lot of DirectX. I'm not going to drill down in DirectX. There are very, very good talks around build now to leverage DirectX to write, very fluid UI, a lot of, 3D camera shading, shadows, a lot of things. We use C++CX, of course, to interact with WinRT. When you go to the file picker to look for the photos of your kids, you basically use WinRT, right, to interact with the streams, the open picker, or other things like the database where to save the strokes and so on. And then we use, more technical things like auto-vectorizer to speed up our loops, or C++ AMP for, to speed up ink smoothing and page curling. And in general, it was fun. Like I said, we put the code on CodePlex, so it's open source, I guess. It's technically open source. It's really open source. Some of the guys, I didn't write anything, of course. I'm a manager. These guys wrote it here, and you can ask them the real questions. So let me drill down mostly on the slides about these three concepts, right? Modern C++, what do I mean by that, right? Actually, Herb Sutter wrote a very nice article that we put on MSDN on our blog. But by modern C++, when I think about it, I basically, the short version, I just don't want to see delete. If I search for delete, I just want to find comments, right? I don't want to see any more deletes, right? Hopefully, no more mallocs, no more all that stuff. And, and maybe not even news, right? Just use make shared and, go back to news when you really need it in your libraries and so on. So in general, a lot of standard C++ library, STL, streams and so on. PPL for task and continuation. So you create a task, and when that task is done on some other thread or whatever, then you continue with another operation. And of course, leveraging Boost, that is a kind of a completion of the standard library for us. Smart pointers instead of raw pointers everywhere, of course. RIAA pattern everywhere. And for errors, of course, use exceptions. And in general, coding convention, we were inspired by Boost, so a lot of lower cases and so on. We're going to see just a quick example, but basically any random file you open inside the Austin project, the journal project, is going to look more or less like that. I mean, we are not going to be super precise, but that's how this is real code. This is a real application and works. It's not just a sample app that does a couple of things. DirectX was key for us, right? So we needed, from the beginning, we knew we wanted something very fluid, very fast, so we knew we were going to use DirectX. And we basically build a 3D scene, and each page is a 3D model. That is very simple, of course, but you can actually, turn the page. And there is interesting physics involved in how to turn the page that, does it feel like, a piece of cloth or a piece of paper? So it's not super straightforward, but people study these things, and we leveraged a bunch of things that were already written or researched. So another thing we did, we abstracted a little bit the complexity of DirectX with a small library that is inside the project, because it is a 3D application, but it's not a game, of course, right? It's not shooting or models moving around. But, you see 3Ds and shadows and so on. So, another thing we did, like I showed, we interact with XAML UI very well. So most of the things is DirectX. But some important parts, some easy part to write, we just use XAML UI. And it's much easier to write, Windows 8 specific menus and flyout and so on, and have the two things composed. XAML UI takes care of compositing the DirectX, scene with the XAML UI things. And everything really goes down to DirectX underneath. So everything is GPU accelerated on your machine. So that was pretty simple for us. I'm going to show you a couple of things there too. And finally, C++ CX. C++ CX is our way to talk with Windows and to talk to other languages. Austin is just basically one big exe. There are two static libraries that gets folded inside this exe, but there is no JavaScript, no C#, so we don't need C++ CX to talk to other languages, but we need C++ CX to talk to Windows. Windows gives us some very powerful services like a database. It tells us when to start up, when to go to sleep, when to save. It tells us, how to find files, how to save files on the web, when we want to share, and you go on the right, and share something. So it's really useful for that. But we were actually extremely careful in keeping C++ CX just at the boundary, right? So we were really explicit about that. And actually, we succeeded because if you search more or less for ads, that is a rough way to find where C++ CX is involved. We just really have like 5% of our code base, if not less. I'm not saying this is the only way to do it. I think it's fine to let bleed C++ CX a little bit more into your project, but it's definitely possible not to, to keep it at bay and creating enough abstraction around that. If you care, if you need to port, most of your C++ code to other platform, or you have existing C++ code, right? So you don't need C++ CX unless you need to interact with the OS. Let me show you a little bit the code, right, to show you that is actually. I had to press the magic button again. And I have Visual Studio open with the. You can see the solution here. There are these three projects. This Baja is a static library where we do most of our 3D abstractions, basically, our 3D engine abstraction. This one is just an helper library from DirectX to load texture. And the big application is really here. This journal creates a big exe, optimize the hell out of it, and we are happy, right? So the first piece of code is I just found, one of the first C++ files. And, there is a lot of WString, shared pointer, shared pointer again, standard vector. We use the new for loop. We use auto. So we do use, the idea is that I want to show you just with one page of code, it's modern C++, right? You're not going to find many news. You're not going to find deletes, right? And it's pretty simple to write code like that. You don't have to think which container do I use. You always use vector and so on. We wrote this code mostly from scratch, so of course it's much easier when you do that. But we wrote a bunch of code, right? So, and we created the right abstractions to create, small classes and so on to actually keep this going. Another thing I want to show you is the XAML integration. So this page here is actually the page. It's called page.xaml. It's a very good name. And if you look in the document outline, you can actually find, the up bar. You see? Actually, is there. The up bar, for example, or the color flyout that I was using before, or the pen flyout. So it's much easier to draw all these things in XAML. There's a bunch of, I don't know, what are they? Are they rectangles or images? They are controls mapped together. So it's much easier to write them in XAML. Maybe not you, maybe your super cool designer, the one with the nice sneakers and so on. But no, I'm not saying that you're not cool. I didn't mean that, sorry. I mean that they are cooler. To interact with that, use C++ CX. Very natural again. The border is very clear cut for us. So take this as an example. And when your app is heavily DirectX, so you have a lot of DirectX content, and just the Chrome needs to be Windows 8 because you want to feel, like a Windows 8 application. Do you use XAML UI? I think that's a winner. Instead of you trying to draw these things in DirectX, that's going to be fun. So that's what I wanted to show from. And the code is here. You can just go around and search and find stuff. I'm going to show you a little bit more about how we vectorize the things and so on. So, okay. So what do I want to talk about? Now we go into, this was simple, right? This was easy. Write C++ code, DirectX is not easy. You need to learn it if you don't know, or, master it. But, someone else is going to explain that. But now, we had some problems. For example, one of the key things in, making a very natural feeling for ink is the smoothing, right? When we draw, we are actually drawing segments. We are polling and seeing where your pen is. Windows tell us I move my hands too much. I'll stay calm. Windows tell us, the various points, but we like to actually smooth the curve and add more segments. And so this is not nice, but we want to do this. We want to smooth it out. I hope that you can see the difference from far behind. And we want to do this in real time. So this is kind of the trick here, right? So the algorithm to do this, are well studied more or less. But we have, kind of 5 milliseconds or less to do it, if you count the frame per second and how fast you actually draw around and so on. So this is the algorithm actually to do the smoothing. Very simple to understand. I have actually, if you're really interested, actually, I didn't tell you about this. About Project Austin, we have a nice series of blog that goes in detail. So if you go on VC blog, and I have the link at the end of this presentation, they actually will go into the details about, how ink smoothing work. How did we come up with this crazy algorithm here, or these mathematical things? How do we invent the page curling and so on? So if you want more detail, go there, and I have some slides as well for the mathematically oriented. But anyway, so the key here, in my opinion, is that we are writing this in C++. One of the great advantages to write this in C++, in my opinion, is that my devs that writes the backend of C++, they are obsessed with optimization, right? So they are going to try to optimize your code. The compiler is going to try to understand your code and write the best code, emit the best code possible. And with the new vectorizing capabilities of the new chips, we can speed up this type of loops. Can I do this? This type of loops is actually very relatively easy to parallelize, because there is J and T depends on J, and everything here depends on T and on J. I mean, if you just look at it, it's not very clear, but the compiler knows this because it creates a lot of structure to understand this type of scenarios. And this one, no, we'll just use the auto-vectorization. You could use C++ AMP, but we'll have another example that is even better suited for C++ AMP. And we could drill down on when to use one and the other one. So we just wrote this, and just to be clear, how many of you know when I say auto-vectorization, what do I mean? The new SSCT instruction, very good, yes. So this is a very super simplified view of what auto-vectorization means. There is a very nice talk tomorrow from actually one of the optimization-obsessed guy, Jim Radigan. So go to that talk, it's going to be fun. And Don McCready, that is the C++ AMP obsessed guy. So basically what's happening here is like that. So you have this loop, this very simple loop, but the compiler basically, under the cover for you, translate this loop in something like that and use these new instructions to actually do 4 sums at a time, instead of you doing one sum and then 1 other sum and then 1 other sum and then 1 other sum. So you're basically speeding it up like 4x in this case, roughly, So that's very nice, right? So in the old days, you had to know about this instruction, write inline assembly or assembler outside. The inline assembly is going to screw up the optimizer anyway, so it's basically not gonna happen, right? So you just write these. You don't have to care about all these at all. You write these, you compile with optimization in retail mode, bam, your loop is vectorized, So this is great. This is great because it helps. And for us, it gives us those 5 milliseconds we actually need to smooth, right? So as you can think about the code, it's not super easy to tell from up front if the code is going to be auto-vectorized or not. So the compiler, actually we put some special switches in the compiler to actually tell us if some loops are vectorized or not. So you have to go in the command line option and put them by hand, because we didn't have time to put them in the things here that I never find anyway. So you can do these, or you can do qvec report 2, maybe a colon here is missing, and reports, the loops that were vectorized and why they were not vectorized. So for the code I just showed you above, we were lucky in a certain sense. It got vectorized right away. But this one, for example, what do you think is going to get vectorized? So we are doing very simple, the sum of b and I based on I. What do you think? Sides, not good. You are too good. So yeah, but the compiler, if you throw that qvec report 2, is going to tell you, oh, the loop is not vectorized to reason 501, and everybody knows that this is the Levi's brand. It's not. So how do you do with 501? You go to the web, and there is actually the link that I put in my, or you Google it, or you Bing it, whatever. You're going to find it eventually. And it's tell you, really, 501 means the upper bound is not loop invariant. That's what you guys thought about, right? And basically, in this case, this bound is like our sides. And the optimizer is not sure. Is that size going to change all the time? How do I know? So basically, you have to write this code. Basically, put Imax, take out, make the upper bound loop invariant. And so if you change the code like this, the qvec report 1 or 2 is going to be happy. It's going to say, yeah, let's do it, man. So you get 4x speed up here. Nothing to sneeze about. So like I said, it's not, so these are trivial examples, of course. Please, question. Yes, that's a very good question. So the question is size a const expression? Why the compiler is not smart enough to figure it out, and why? I had kind of the same complaint to my guy, and they say, yeah, you're right, but we still have to add a few tweaks. So as we improve, the vectorizer, the backend understanding of C++ concepts like const expr and so on, we are gonna get even better at understanding your code and understanding the semantics of your containers or whatever you want, right? Sometimes you need to do some pre-optimizations like this one that is explicitly telling the compiler, look, I really know that this is not going to change. The compiler should technically figure it out. Then again, the compiler cannot figure out that, that A, you should see that A is a local here, and so it's not changing, and nobody else has access to it, and we don't take references to it, and blah, blah, blah. So it's creating all this mega graph and figuring out this. But, that was a good question anyway. So, yes, auto-vectorizer at work. For the zinc smoothing, we got a 30% speed up overall of the algorithm. And for the first part of the page curling is another compute-intensive algorithm. So that one we got even more speed up because, there's more data and so on. It goes very fast. So like I said, auto-vectorizer can analyze very complex loops. The example I had before, the A, B plus C, is very, very trivial. But it can do a pretty good job. I'm going to show you now a pretty beast piece of code. And the idea is that don't obsess over vectorizing each loop, right? Understand which loops you really care. They are really giving you the speed up you need to be more responsive, to put the CPU consumption down, many situations, but measure. Like everything in performance, you always start with measuring, and then you go turn the screws a little bit, tighter or less. And to figure out the 501 messages, just go to the guide here or send us mail. Please, question.
Is the auto-vectorizer always turned on, or does you have to turn on?
Very good question. Is the auto-vectorizer always turned on? Yes, it is always turned on in retail builds. So when you do O2, I guess, or OX, probably not.
That you're building for something that has C2, or do you not support
So second question is, do you have to tell the compiler that you're building for SSE2 target, for a target machine that supports SSE2 instruction and plus? Actually, from Visual Studio 2012, we assume that you will always target a chipset with SSE2 plus. You can turn that off, but that's the default. So let me show you 1 second an example of the code that is actually less trivial than, well, the one we saw before at the beginning is less trivial. But in the output here, we have QPAR1 reported. So I don't know, can you see? So it's actually saying that this page curl has been vectorized. So if you double click there, so this is the loop that is being vectorized. It's not really, to rewrite this in assembly and SSE2, yeah, it's going to take some time. So in this 1.75x speed up. So not bad. Huh? Nice. So it's pretty smart that you did there. What else I want to show you? Yeah, these for example, is the website, is the MSDN page with all the examples and the various code. So it's mostly based on code examples, so they are the easiest one to understand, in my opinion, than people writing a lot of English. So second part, there was a question about C++ AMP versus auto-vectorizer. So for this one, I had to go back to my notes. And sorry, I should have stayed here. Because I want to show you what I'm talking about. If I go here, I actually draw something, So if you see here, this is how the page curling works. So the idea here is to actually, the model we use to curl, to turn the page, is we wrap it around the cone. See here, there is a cone. You can see here, there is a cone here. And we kind of simulate there is a cone, and as I turn, I'm wrapping the page around the cone. So as I'm turning here in real time, we are calculating how all these triangles, they make up the page, wrap around this imaginary cone that is here. So there is a piece of code that is actually calculating based on the position of my finger, how much we are wrapping around the cone or not. Or when we grab it from here, we are wrapping around the cylinder. So that's kind of the first part of the algorithm. So you have to calculate the position of each triangle. See the triangles here are kind of turned a little bit. They're kind of turning up. So the second part of the algorithm is if you see the shadow, the color is changing. You probably don't notice, but it actually makes you feel more natural, right? Without even you noticing. So actually to calculate the shadow like that is, again, not super trivial, right? DirectX needs to know where the light is and how the triangles are oriented. To know how the triangles are oriented, we calculate the normals of the triangles. If you go back to high school, all the stuff was actually useful. And so you calculate all the normals that is the usual cross of if the 3 points here. I didn't remember, but when you read the blog, you remember. You say, that's stuff, right? The cross. That was it. So, but this is not even enough. We calculate this for each triangle, but to be more precise, we want to actually calculate the normals of the vertex. We want the green normals, not the red ones. So this is a little bit technical, a little bit graphics technical, but I'm showing this example because as you see on this page here, there's probably a lot of triangles, right? So it's really a massively parallel problem, right? So we have to go on each triangle and calculate the normal of each triangle, and then on each vertex, we have to calculate the normal of each vertex based on that information. So this really screams like massively parallel. And you can make it, if you make it fast, you can have a lot of triangles, so very good accuracy. If you make it slow, then you have to reduce the number of triangles, and it's not going to look as smooth and so nice, but at least it's going to turn in real time. So it's a balance there. So let's go back a little bit to the code. And this is actually the code. The code here is, here is calculating the vertex. Here is calculating the cross, so the triangle normal. And here is calculating, basically this is the red normals for the triangles, and these are the green ones. So basically, like I said, there is lots of triangles. For each triangles, we just, we have to calculate, we have less than 15 milliseconds to turn the page. So we need to be very fast at calculating this stuff. If not, it's not going to look good. So like I say, C++MP is a good candidate, so let's go ahead. Let's figure it out. So right now, this algorithm, like this, is a single-threaded algorithm. So let me go through that. Because it's for each triangle, this one is easy to parallelize because it's only all the information here depends on the triangle itself. But if you look at this one, this part here doesn't depend on the triangle itself. It depends on the information of different triangles. So you got a race here. So because if you run this just like this algorithm on multi-threaded, you're going to get very weird normals because these ones are going to be calculated fine because you go on each triangles on different threads, and that's perfectly fine. But to calculate the second part, you have to put together the information, and it's going to come up at different times, so you're not going to get the right thing. So to parallelize this thing with C++AMP or with parallel task or whichever TBB, whichever parallelized you want, you have to change the algorithm a little bit, first thing. So the first thing we change, I kind of simplify the algorithm. First we calculate the triangle normals, then the vertex normals. We kind of split the two loops. Now we have a loop for each triangle and a loop for each vertex. And now there is no race here because to calculate each vertex, we are just reading data. And the data we need to read is actually coming from this baby here. So basically, we cache all the triangles normals, and we feed them into the second loop. So if we use C++AMP now, we really want to do all of these on the GPU, right? So we want to tell C++AMP, basically the C++ compiler, look, I can do this on the GPU, this on the GPU, and the cache better stay on the GPU as well, because I don't want to go back to the CPU memory and then go back to the GPU again. Every time you copy, until we have zero copy, memory that can be accessed both by the GPU and the CPU, every time you copy, you incur an extra cost, right, that you wouldn't have on a normal, scenario. So to make it a little bit short here, that's the first loop looks like that, This restrict ampere is telling the compiler, try to put this on the GPU. If you have a GPU that DirectX 11.1 enabled, that does DirectX compute, emit code for that GPU and run it on the GPU. And this is the same code that we had before. We just changed it a bit, the for loop, and it's a parallel for. And this basically is actually the cache, and is a concurrency array that is going to stay on the GPU. So we put it on the GPU, we cache it there, and stays there, and then we use it in the second loop. And again, it's a restrict amp loop. And we go through each vertex now, and we grab the temporary we were using before that is on the GPU. So this one depends on the GPU, depends on the size of the project and so on. We are talking a 3x to 7x speed up. So a serious speed up here, right? It really makes us do the curling with a lot of number of triangles in real time. So this is important for us. It's important for an application like ours that is real to life, that we want. We are not just geeks that want to go faster for whatever. We are, but there is something that actually comes out of that fastness and so on, right? So, and the other thing is that the CPU, if you push stuff to the GPU, is actually free or to fall asleep. That is always good for battery consumption, or to do other stuff, right? Other code faster. And even if your device is not DirectX 11 capable yet, I think the one I'm running on is not. It's a bit older. But there is Warp that is actually from Windows as a driver. So Warp is actually going to simulate the GPU and emit SSC2 and use SSC2 instructions or SSC4 as well, just SSC2. SSC2 instruction to go fast, and actually, if your size is not too large, you get a very nice speed up from warp as well, because you stay in the L2 cache, and so everything is inside the same memory, and it's go pretty fast. Once you go to really massively parallel problem, SSC2 is 4 times, it can do operation like vectors of 4, of 8, but the GPU has thousands of cores that keep on working in parallel. So you get a very nice speed up. Oh, I have the book about C++ AMP. You should go get it. It's signed by the author that is somewhere there. So we are almost done, are we? Yes, kind of. So basically, key takeaways. So use modern C++ whenever you can. Remodernize your code when you have a chance. That's what we are doing with our code base. We are doing it in our compiler. We are doing it in the backend compiler. We are doing it in the libraries, in Visual Studio as well. Use more, R-value references, lambdas, const. These are all things in the language that gives you, powerful semantics to actually make your code faster, better understood by the compiler, so the compiler can do a better job at optimizing it. And use standard libraries, or Boost, or other third-party libraries. Don't reinvent the wheel all the time. DirectX, super key for this type of application, in my opinion. This real-to-live application really scream for, a lot of details, a fast interaction. So DirectX is really your friend here. And C++ and DirectX are best friends. So that's one reason why you want to stay there. XAML UI, very well integrated in the same composition layers with DirectX. So don't be shy about using XAML UI when you have a DirectX application. You're not writing a game, right? So you don't have a complete engine that does, fonts and everything and buttons and so on. So use the buttons and the fonts and all the cool things that XAML UI gives you. And, use your DirectX surface for, fast 3D. Another very cool application that is written this way is FreshPaint, if you've seen some demos. Very nice application, very large canvas that is all DirectX. There is a lot of HLSL code actually to simulate the strokes of a real paintbrush and so on. And it's actually very cool. And it's basically the same code base, right? If you look at it, there is a lot of XAML UI controls, but then the main surface is DirectX. C++ CX, again, to talk to Windows and other components and other languages. If you want to, if you need to talk to if JavaScript needs to talk to you, it's better you create a C++ CX layer and so on. Autovectorizer and PPL. We didn't talk about PPL, but it's actually another way to parallelize your code. Basically, you write a parallel for, and this gets distributed to a set of worker threads, basically. In this way, you distribute the work on the CPU. And the C++ AMP is to leverage the GPU for massively parallel problem. I think the size of the problem, going back to the question is, when should we use C++ AMP? When should we rely on Autovectorizer or PPL? The talk from tomorrow, I'm going to have a pointer to tomorrow, is going to really drill down in this kind of scale. Autovectorizer, PPL, or TBB, and C++ AMP, kind of a crescendo. But it's really sometimes really about the size of the problem. So bigger size, C++ AMP is your friend. These are my kids. I always put them in. So C++ rocks. C++ rocks, go great. Write the apps. I really think it's a great opportunity. And I didn't have a talk about the store, but I was in another place. I talked about the store, and it's just begging for more application to be written. And I think it's a great opportunity. It's also very nice economics. But, it took us a while. And, one thing I didn't put here is it wasn't super easy to write this application, right? It's not a walk in the park, right? Well, let's write, a page turning, ink smoothing, super cool, with shadows and so on application, right? I show you a couple of tricks, things that we learn, and we have actually in the blog we have more. Another interesting problem is how do you save all these strokes that you write, right? I'm writing and juggling and coloring and canceling, and the application wants to go to sleep, or I turn it off. We used actually a small transactional DB that is inside the EasyDB that is inside the Windows to actually save each stroke. And then, as your notepad becomes very big, the one I'm using at work is actually much larger than this. With the DB, with the database in the background, it's very easy to just, stay focused on the 3-4 pages that you're working now. And then we load up the other pages as you scroll and so on. So that's another interesting problem. And you have to solve it somehow, right? So I'm saying it's not easy, but it's rewarding. And I think the customer outside will reward these kind of applications. And so I like the app. And every time I show it, people say, wow, that's pretty cool. Is it available in the store? Not yet, right? Not yet, but soon. Maybe. Resources, this is interesting, right? So we are just the first day. Just before me in this room was Tarek Maktour with the, moving existing C++ code. But just this afternoon, there is Casablanca to talk to REST services and write, services in the cloud in C++, like Node.js, but in C++. Pretty cool. The same dudes that wrote PPL and Parallel 4 and the task-based stuff. So if you like that kind of, it's a very nice library. I really like it. And it's needed for C++ because accessing REST from C++ is such a pain, yes. So this one tomorrow is the one I've been talking about today a lot. This one talks about C++ AMP Octovectorizer a lot. So the backend guys are here. You really want to go to this one if you're interested in the talk today. DirectX is here. I think it's one of the many talks. There are a few talks. Games talks or DirectX code is there. I saw other talks about DirectX application and DirectX and, C#. C++ CX, if you need it. And, XAML and C++. This is another application that we created to understand the feasibility if you have the right tools. And this Herb Sutter, that is always super cool on Friday. So always have some special news for you guys. So cannot be missed. Herb is great. So these are the other resources. This is the blog. These are the kind of the various blogs about Project Austin. The link on Codeplex, AMP, my email. Send me email. Send me about good things, bad things, everything. Good feedback, bad feedback. I take everything. Feedback is always useful. Talk to me if you want to talk with. I have a few C++ guys here walking among you, but we are in Redmond, right? We are at home, right? So you want to talk, have lunch with us, see our building, see the office with 25 machines, all warm and so on. Come over, right? We are here. We are here for a week. You're here. If you have an hour free, just send me mail. Send mail to Eric that is going to be around at the booth. And if you have a problem, let's start the discussion, right? Having the connection in the team, if you have some C++ problems, it's great for us. We get very good feedback. We tell you, oh, we are doing this, we are thinking about this, or we are thinking about deprecating this, and you tell, oh, please, we really need that. We're going to deprecate it anyway, but that's okay. So I hope so. We never deprecate anything. So this one is cool. So another thing, actually, if you want to be part of a small design, usability study, just feel online here or let me know. And, I have business cards here with my email and so on. So these are always very nice data that we actually leverage a lot. When we are thinking about, how to shape the PPL tasks, I remember at the last Build conference, we had a few people participating in this, and it was actually very useful. We showed them, do you like this more? How do you want to deal with exceptions? This way or the other way? And, it was very good feedback that we actually pulled back inside our library. What else? No, that's it. These are the mathematical stuff. Ooh, scary, man. Okay, so are we? We still have time. We still have time for questions. So we have the microphone, so I can repeat the questions, whatever you prefer. Thanks. I think we had questions during the meeting. Yeah, please. Oh, microphone is on now. Go ahead.
This might be a controversial question, but do you think anybody might be able to write a XAML app with C++ for the desktop anytime, ever?
Yeah. So it's not really controversial, but for the moment, no. Right. We understand that we don't have a good desktop story right now. Some UI is not available on the desktop in Windows 8.
Right.
The feedback is clear, but I can't tell you anything else at the moment.
Very good.
But you would like to use it, I guess.
You didn't tell me to get lost, so that's something.
Yes, I didn't. Yes. How many of you write modern apps versus desktop apps? A lot of desktop applications? Yeah. Yeah, I guess. It's both, right? Yeah, of course. But the AMP and the vectorizer is going to definitely work on desktop. But we are talking about UI application. UI is very good. I mean, DirectX, of course, works, but XAML UI is not there. So it's tricky, right?
Are the vectorizers roughly equivalent on all three CPU architectures, 32 and 64 and ARM, or are they
Very good.
some better than others?
The question is, are the vectorizer kind of roughly equivalent in the code they generate on x86, x64, and ARM? I mean, we don't know. I think so. I'm not 100% sure. Take these questions. I believe so. Take this question tomorrow to Radigan and Don McCready. So it's going to be good. More questions? Please.
Is there a penalty for using C++ if code going to be compiled for ARM?
Oh, is there a penalty for using C++ AMP if you're actually targeting the ARM chipset? As one of course, yeah. Usually when you upload an application to the store, you have to upload definitely the ARM version and the x86 or x64 version. So Amit should be able to answer this one.
No, as a penalty, I mean performance penalty.
Yeah, performance penalty.
So you mean runtime performance penalty? Yeah.
You can go to the. You can go to the.
Runtime performance penalty. So I mean, so if you use a C++ AMP code, it all depends on whether you have any accelerators available on the machine. Right now, on ARM machines, we don't have any DirectX 11 hardware, so that code will actually not run. You get a runtime exception. But when WARP eventually does come around to being supported in ARM, then your code will actually run on the CPU, multiple cores, and the vectorized instructions.
Okay, so answer is that currently it actually wouldn't even work.
Yes.
You wouldn't leverage ARM, right? That's the point. But as new hardware comes up, and DX11 is going to be supported on these ARM machines, the GPU is going to all the code is going to run on the GPU, right? So
is Project Austin going to have alternative branch when compiling for ARM?
do we have different branches in the code that we emit?
So it'll check if it does have any accelerators. If it does not, it'll actually fall back to branches.
Oh, okay.
Yes, so you're not going to die. Your application is not going to die. So it's going to check, can I run on something better than the CPU? If not, it's just going to go back to the CPU. So. Please.
What do you recommend for interop with .NET? Is that C++ CX? Managed code.
Sorry, what do you recommend for?
For interop, is it pretty much pinvoke still?
Oh, interop between, yes. So interop between C++, native C++ and managed code like C#.
C#.
Are we talking in a desktop application or in a modern application?
Yes, desktop.
Both. So in a modern app, we do not support C++ CLI. So your interrupt story is C++ CX. Write your DLL with the C++ CX layer, and that DLL, the C++ DLL, you can call the C++ DLL from JScript, from C#, from whoever implements WinRT. And that's very, very smooth, very nice. It's very similar, basically, to just make a very light COM wrap on the Windows Store app. But on the desktop applications, C++ CLI is your boundary story. Please, other question.
Is there going to be any way to do WinRT on the desktop instead of having to manage the C++ CLI and the WinRT version?
Very good question. The question is going to be something like C++ CX on the desktop, like WinNDs and all that thing on the desktop, so we don't have to write wrappers for our DLL in C++ CLI and in C++ CX? No, not for the moment. Never, I don't know. Never say never. The desktop store is going to definitely evolve, as Windows evolves, and the languages, the syntax of the language is very similar for us. So hopefully it's not too much work already, but it is interesting more. So we should definitely talk about how much overhead you're incurring in this case. What we ship right now doesn't support that. That's what the answer I'm giving you. I'm not stating, we're not going to think about that in the future, right? How we answer these things, how we look at these, I'm opening up a little bit here, but how we look at these things in the future, it depends how many people are actually going to need these interop layers, going forward. How many applications are going to be like just, C++, native C++, or how many are going to be C# or JScript and C++. So that's definitely going to make us invest in one way or the other way. Yep. Please.
How much of this is applicable to Windows Phone?
Oh, very good question. How much of this is applicable to Windows Phone? Windows Phone 8 does support DX11. Does not support AMP because there is no DX11.1 drivers. But vectorization works perfectly. PPL works perfectly. So it's just C++ AMP does not apply really.
Is there any way in C++ to render the XAML visual tree to a bitmap?
Good question. So is there a way, you already heard the question. I don't know, it's really a XAML UI question. So you basically want to get a picture out of your XAML UI, basically the UI you're driving XAML. There might be, I don't know. If you send me mail, I know the guy that knows the answer. I know I don't know it. But I know everybody almost now. So I've been here too long. Don't forget to send me mail. More questions? It was great. So you're going to get the phones and the slates. That's pretty cool. Yeah. I had to convince my wife to get one. Thank you, guys. It's always nice to talk to you. Oh, if you want some C++ AMP books, I have 4. So the first 4 people that want one. Hey, we have more in the booth. So go to Building 92 and look for Visual Studio, Visual C++, and we definitely have more books there giving out.
Business card?
Oh yeah, of course. Thanks, of course.